Richard Feynman, who won a Nobel Prize in Physics for his work in quantum theory, famously remarked, "I think I can safely say that nobody understands quantum mechanics." What he meant was that the fundamental principles upon which quantum mechanics is built are mathematically abstract, so they don't make sense in and of themselves. About our efforts to understand quantum mechanics, Chris Fuchs notes, "Where present-day quantum foundation studies have stagnated in the stream of history is not so unlike where the physics of length contraction and time dilation stood before Einstein's 1905 paper on special relativity. In his struggle to understand time dilation and length contraction, Einstein wrote, 'By and by I despaired of the possibility of discovering the true laws by means of constructive efforts based on known facts. The longer and the more despairingly I tried, the more I came to the conviction that only the discovery of a universal formal principle could lead us to assured results.' In other words, Einstein reverted to principle explanation, where one simply articulates the mathematical consequences of empirically discovered facts. In this case, Einstein said that the relativity principle demands the invariant measurement of the speed of light, and today very few physicists complain that we don't understand special relativity. In response to this state of affairs, quantum information theorists like Lucian Hardy have reorganized the mathematical structure of quantum mechanics in an attempt to discover information theoretic axioms at the foundation of quantum mechanics that make sense, starting in 2001 with Hardy's own paper, Quantum Theory from 5 Reasonable Axioms. Indeed, today, there are many axiomatic reconstructions of quantum mechanics based on information theoretic principles. And quantum information theorists like Marcus Muller are excited about their discovery. Muller writes, "Can quantum theory be derived from simple principles in a similar way as the Lorentz transformations can be derived from the relativity principle and the constancy of the speed of light?" The exciting answer is yes, and our group has made substantial contributions to this research goal. But the fundamental information theoretic principles in these reconstructions of quantum mechanics are not nearly as transparent as the relativity principle and light postulate of special relativity, so the foundations community remains skeptical. Wesley Van Camp writes, "Nothing additional has been shown to be incorporated into an information theoretic reformulation of quantum mechanics beyond what is contained in quantum mechanics itself, and so it is not offering any explanatory value on this front." In no preferred reference frame at the foundation of quantum mechanics, physicist W. M. Stuckey, mathematician Timothy McDevitt, and philosopher Michael Silverstein respond by showing how the axiomatic reconstructions of quantum mechanics based on information theoretic principles reveal the relativity principle at the foundation of quantum mechanics precisely as it exists at the foundation of special relativity, that is, in demanding the invariant measurement of a fundamental constant of nature, the speed of light c for special relativity, and Planck's constant h for quantum mechanics. Thus, it is no longer true that nobody understands quantum mechanics, unless it is also true that nobody understands special relativity. Very few physicists would make that claim.